Welcome to lecture 9. This is our final lesson for this semester, and today we are going to be talking about landfills. So the first thing we want to talk about is what is a secure landfill, because a regular landfill is not necessarily a secure landfill. So a secure landfill, this is a carefully engineered depression in the ground, or it may be built on top of the ground, and it's roughly the size of a football stadium, and we put our waste into that depression. So this defines a landfill. Now if you recall, we have been talking about the entire solid waste management hierarchy, and we had actually listed landfills and even incineration as some of the least preferred solid waste management methods. So today we are dealing with the absolute least preferred, which are landfills. Okay, so what is the objective of landfilling? With secure landfills, a secure landfill has an objective to avoid any hydraulic or water related connection between the waste that you put in the ground, and you're trying to avoid allowing opportunities for water that would mingle with that waste to get into your groundwater, because once it reaches into your groundwater, you know it can make its way into all the various paths of our hydraulic cycle, whether it is surface water, groundwater, it gets into your rain, etc. All right, so your objective with a secure landfill is to avoid that. Now, as I mentioned before, not every landfill can be considered secure. There are 4 critical elements that you would have to look for to determine if a landfill is secure. And these 4 critical elements are, firstly, the landfill should consist of what we call a bottom liner, must have a leachate collection system, a cover, and natural hydrogeologic setting. We're going to look at each one of these in turn. So before we do that, here we have a schematic of a secure landfill that meets all those requirements. So here, first of all, let's look at our geologic setting. We have our bedrock, we have our water table where the water has accumulated on top of that impermeable bedrock. Then beyond that, we have our impermeable layer. Now this impermeable layer is what we call our vadose zone. So this is our surface here. Notice we have a monitoring well positioned in this zone here. Okay. Then leak protector. All right, it's a monitoring site. Then if you follow with me here, we see this black line represent our liners. These are the bottom liners we were talking about. So the purpose of that liner is to prevent anything such as contaminated leachate to reach into your groundwater. Notice we also have a leak detection system associated with that at that layer. Okay, above that we have our leachate collection system, which is our leachate drains. Okay, and the leachate would drain in a particular direction where the leachate would be redirected to a wastewater treatment plant. On top of that, we have our waste that would be accumulated, and then we have our cover on top of the waste. Okay, so this actually should put into perspective the 4 elements that we just mentioned. So let's look at it in some detail. So first, again, we have our bottom liner. So our bottom liners, remember, it's essentially a protective barrier. It can be made of, it can be as thick as 1/10 of an inch, and it may be 1 or more layers of clay. So it could be clay, or it could be synthetic flexible membrane. In other words, it could be something like plastic, or it can be a combination of both of them. Now you want to be very careful. You're designing your secure landfill to ensure that the bottom liner does not fail, because if it fails, waste will migrate through leachate directly into the environment, as I mentioned. And then of course, as we said, you have the three types of liners. It may be clay, maybe plastic, or you can combine both of them to strengthen its resilience. Let's talk a bit about the leachate collection system now. So leachate, let's make sure we understand what leachate is. Leachate is the water that will mingle with the waste that will get badly contaminated by the waste, because remember, as the waste begins to break down, it will release certain gases and chemicals into your water. So this so if rain falls and mingles is allowed to mingle with the waste, you have the development of leachate. So this leachate would seep to the bottom of the landfill and is collected by a system of pipes. So those are the pipes we saw on the diagrams. All right, so the water would migrate to the bottom of the landfill, and because you have your bottom liner, is no longer allowed to go further, and it will be collected by those system of pipes. The pipes would be laid along the bottom to capture the water where it accumulates, and then the leachate that is collected would be pumped to that wastewater treatment plant that we just mentioned. So what happens at the wastewater treatment plants? What happens is the solids are removed from the leachate. So it would be the leachate will be a combination of solids and liquids. So they remove the solids during this step, and the solids will be returned to the landfill. All right. So this is what happens at this stage. Then we're moving higher up the structure of the landfill, secure landfill, and we're talking about the cover now. So remember, it's going to be important for you to cover that that accumulation of waste that you have deposited in that depression, right? So you want a cover or a cap, and this cap functions like an umbrella to keep the water out. It generally consists of several slope layers, and what those layers, that the cover or the cap, firstly the first layer would be also clay or membrane, similar to the kind of material you use for the bottom liner, and that is to prevent rain from getting through to the accumulation of waste that you have deposited there. Then on top of that, you will have a permeable layer this time. So this one actually allows the water to get through, so that when it gets through now, it will run off of the liner, right? So remember, the liner is impermeable. On top of that, we place a permeable layer, and then on top of that permeable layer of sand or gravel, you will now place topsoil in which vegetation can grow, and the intention of that topsoil is to stabilize all these layers that have been developed to function as a cover for the landfill. All right, to avoid soil erosion and the washing away of that permeable layer of sandy or gravelly soil. Now the thing to note is, if the cover is not maintained, rain will enter the landfill, resulting in a buildup of the leachate, that dangerous leachate we were talking about. All right, so if it, remember, the landfill comes like a bathtub. So if the water is allowed to go in now, it will begin to accumulate and it will overflow the sides, and water and waste will now get into your environment. So the purpose of the cover is to prevent that from happening. And then we have our natural hydrogeologic setting. Now when we talk about hydrogeologic, we are talking about what's happening under the Earth's surface. What is the geology or the arrangement of the rocks beneath the Earth's surface, and how does water travel through that arrangement. Okay, so in order to prevent the waste from escaping, you want rocks as tight as possible. So you want the joints or the spaces between the rocks to be very tight. You don't want, because you don't want water to be able to easily flow through those cracks. The geology should also be simple, right? Because when it is complex, meaning you have a lot of complex cracks and paths within the rocks, it gets difficult for you to really understand or predict how the water will travel through the rocks. So you can't manage that when you can't predict it. Alright, so you want simple arrangements such as block arrangements, angular arrangements. Alright, and once it is simple and you can predict where the waste will go, it means that you're now able to put down monitoring wells or other facilities to capture the waste as it flows through the wastewater or the leachate as it flows through the cracks. Additionally, fractured bedrock is also highly undesirable beneath a landfill because the waste cannot be located if they escape. So remember, we're talking about beneath the landfill now. Fractured bedrock, that's like really deep, hard rocks. So if it is fractured, there is a chance that leachate can flow through there. And now it gets so deep you don't know where it has gone, you can't find it, so therefore you can't treat it or manage it. Additionally, mines and quarries should be avoided because these type of features you will often find them on top of just above groundwater or aquifers. So you don't want to use any of these types of formations to utilize as your landfill sites. Now let's talk briefly about landfill site selection. What are the factors we would look at in order to select a landfill site location? Alright, so we have several points. We have 8 of them listed on this slide. So I will go directly to the next slide where each one is briefly explained. So the first one we're looking at is the available land area. So the available land area that you're looking at must have a useful life greater than 1 year. In fact, it probably should be at least 10 to 15 years. Okay. For example, in Trinidad and Tobago, our Beetham landfill has way exceeded its useful life. It has been in use for decades, even generations for that matter. And we also have a number of other landfill sites across Trinidad and Tobago. They haven't quite reached that stage yet, but this is often a concern. What is the useful life of your landfill area? Because it reaches a point where it's no longer sustainable. Remember, land is finite, and the rate at which we produce waste is increasing. So we have a problem here. How do we manage that? This is why it's so necessary for us to identify, or at the higher levels, all the other solid waste management options, treatment options, as we were talking about before, waste reduction, reuse, recycling, etc. What can we do to reduce the amount of waste that reaches the final landfill site? Okay. So what is the useful life? It should be greater than a year. The whole distance, we've also discussed this in the past. The distance that you have to travel to the landfill site, the greater that distance is, it increases your operating cost. Why? For example, wear and tear on the vehicle, maintenance costs on the vehicle, fuel costs, labor costs. So operating costs will increase the further you have to travel. So you want to look at distance. What is the location of the site in terms of distance to its service area? Soil conditions and topography. So this is this looks at the cover material. So you want to make sure, remember, a landfill cover is critical, a critical element of a secure landfill site. You want to make sure it's available at the site or near the site, because again, this will be related to operational costs. And not only that, you also want to make sure that you're able to cover the waste as quickly as possible for sanitary purposes. Surface water hydrology. So we're talking about what does our surface water drainage network look like? How dense is it? What is the location of our water pathways? Because this will impact drainage requirements, because essentially you don't want to have too much surface water drainage in the area of where your landfill site is, because now you have increased risk of soil erosion and surface runoff. And remember, that's not something you want because it will wash off and erode your landfill cover. Additionally, the next point, geologic and hydrogeologic conditions. Again, what is happening below the surface. As we mentioned before, this is probably the most important factor in establishing landfill site, especially with respect to the site preparation, because as we had discussed it before, you need to make sure that you have simple geology so that you can predict drainage, and if you can predict, it means that you can put things in place, leachate collection systems, monitoring wells, all of these things to ensure that you can minimize the possibility of leakage and leachate travel. Then we have climatologic conditions that must be considered. So provisions must be made for wet weather operations. So for example, in Trinidad, where we have 2 seasons, dry season, wet season, typically what you find is the wet season is a difficult period for operations at the landfill, because when the soil gets wet and heavy and waterlogged, operations to cover the landfill becomes very difficult. Sometimes they have to wait for days before they are able to actually cover the waste. Whereas in the dry season, they can be more efficient about how they cover and how often. Then you have local environmental conditions at the site. For example, if you have noise, if there's, well, of course, these operations will be noisy. Then you have problems with odor, dust, vectors, as well as aesthetic factors that will determine your site selection. So you want to be careful that you're not too close to urban areas or built up areas, because all of these issues, such as the noise, the dust, odors, vectors, they can affect neighboring communities. You would also want to put things in place as best as you can, such as buffers. You can use natural buffers such as trees, etc., to deal with some of the noise, dust, etc. Okay. And then the last point, the ultimate use of the site. So the long-term use of the site affects your management of the site. For example, if this site includes other activities, such as occurs at some of the landfill sites in Trinidad, they have other activities such as sorting and recycling as well, in addition to the landfilling. The way in which you manage this site will be affected, because remember, you have different operations taking place here now. It means that you will have different types of equipment, different operating hours. You will have to have facilities for visitors coming to the site, etc. All right, let's look briefly now at landfill methods. So what we're talking about is essentially the way in which the waste is covered. All right, how do we go about covering these waste, and where do we put it? All right, and we're going to look specifically at area method, trench method, and depression method, and then we'll look briefly at the equipment that they would use at the landfill site. So if you just follow with me, the area method, this is used when terrain is unsuitable for excavation of trenches. So you can't dig down, all right? You're not allowed to dig down because it's not wise, all right? The filling operation usually starts by building an earthen levee. So you're building up a bank with dirt, and then you're placing the waste against that bank and compacting it, right? So you're placing it in thin layers and compacting it against the bank. Each of these, you'll have about a thickness of that waste, compacted waste, and then a height of 2 to 3 meters. And that's what it will be like for the day. So by the end of the day, the operation, each day's operation, 150 to 300 millimeter layer of cover will be placed on top of that waste. Right, so you compact the waste against the bank, then you cover it over with cover material, as we said, right? and then the next day you would begin another set of compaction on top of that. It's important to note that the cover material is hauled in by truck or earth from adjacent land. So as we had mentioned, you want to have access to that cover material fairly convenient to you. Okay, so successive cells, as I mentioned, you compacted one set of waste, you covered it. Now you will compact a second set of waste on top of that first one. This is what we are calling a cell. So you do several of these, all right, until you reach an acceptable level of compaction where they have decided, the exposed would have decided, okay, this is a sufficient height, we go no further. All right, so this is what it looks like visually. Here we have our bank or embankment or levees where earth would have been used to create that. Here we have our waste that is accumulated and compacted against the levee, right? This is stage one. This is our surface ground here, and then we cover it. So this is what we're looking at. This is our cover, right? So this is our cell here. This is one cell unit. Then you see here we have several of them, so they will continue until they reach what they call capacity. All right, that would be determined by the operations expert how much they're allowed to do. So this is what we call area filling. Then we have trench filling. Trench filling is ideally suited to areas where you have adequate depth of cover material available at the site and where the water table is well below the surface. So as the name suggests, trench, you're talking about some digging or something deep here. So a portion of the trench is dug with a bulldozer, and the dirt is then stockpiled to form an embankment behind the first trench. Right, so you have digging and they use the dirt to create an embankment or a levee, as we said previously. The wastes are then placed in the trench, so that's the depression that you just dug, and spread into thin layers, and then they compact that. So they compact what is in the trench. The operation continues until the desired height is reached. Cover material is then obtained by excavating an adjacent trench. So every time they create a trench, they take that and use that as cover material to cover waste in another trench, and they continue this process until it is no longer possible in that landfill site. So in large landfills, equipment that they would use would be a drag line or scrapers in order to create that trench, to excavate that earth and create that trench. So this is an example of a drag line equipment that is being used to create a trench. You can clearly, so this is the equipment here, and you can clearly see a trench is being dug here. And then the next method is the depression method. So this is carried out in areas where natural or artificial depressions exist, right? So natural features such as canyons, ravines, dry burrow pits, or quarries have been used in the past for these methods. Another one would be, for example, the canyon site. So remember, canyons would be like very, very deep depressions in the earth's surface that would have been cut out by the erosion of rivers with very steep-sided faces. For example, we all know about the famous Grand Canyon in the US. So how do they use this? Filling starts at the head of the canyon. So we're talking about the head of the river, the start of the river, and ends at the mouth, or in other words, the end of the river. This practice prevents the accumulation of water behind the landfill. So in other words, if we start at the top, it wouldn't allow accumulation of water, which would happen naturally at the bottom, which would obviously, that amount of water accumulation will wash away your landfill material. So the wastes are deposited on the canyon floor, and from there it is pushed up against the canyon face, so the sides, that those steep valley slopes, all right, to about 1 to 2, an angle of 2 to 1, sorry. So it's very steep and compacted against the sides. However, due to the problem of contamination of local groundwater, development of odors and structural stability, landfills in wet areas are seldom used. So really, if there is a chance that there could be water accumulation passing through the canyons or any of these other natural sites such as ravines, etc., you want to avoid this, because you have now increased the risk of groundwater contamination. Though there may be periods of dry, there could also be periods of wet. So if wet areas such as swamps, marshes, tidal areas, ponds, pits or quarries must be used as landfill sites, special provisions must be made to contain or eliminate the movement of leachate and gases from those completed cells or those compacted waste cells. So the site, what do we do? The site must first be drained, then you line it just as we've discussed before, and this is carried out with liners, just as clay liners or artificial liners, plastic, etc. So let's talk a bit about the landfill operations equipment. Issues for consideration when you're looking at equipment at the site: you need to look at size of equipment, types of equipment, and the amount of the different types of equipment, and these will all be determined by the size of the operations and the methods of operations being carried out at this site. So types of equipment. So some of the types of equipment that you would find typically available at landfill sites would be what we call crawlers or rubber tired tractors. We would be familiar with many of these. So the tractor would be used with a dozer blade, trash blade, or a front end loader. We're familiar with this one, right? What do they actually do? These are the types of equipment. From the front, you find they would be pushing the material forward. So this would be cover material, for example, or even the waste itself, to position it correctly. Spreading, compacting, covering, trenching, and even hauling cover material. Choice must be based on the conditions at each individual site and the equipment available. Right, so the equipment that you need is what based on conditions and what you're actually doing. Okay. Other types of equipment that would be used at sanitary landfill sites would be scrapers, compactors, drag lines, and graders. The next slide actually gives us a visual of what some of these look like. So this type of equipment is normally found only at large sanitary landfill, where specialized equipment will actually increase your overall efficiency. So you wouldn't necessarily find all of these types of equipment at every landfill site, but the larger operations can have many types of equipment. So for example, we were talking about the crawler. I think we're all familiar with this one here, the crawler. So this, as we said, for pushing, spreading, compacting, etc. Now here, I think we might be familiar with this one as well. Here, this is clearly a compactor, right? This will be compacting the waste and, where possible, even the cover, the landfill cover. All right. Here we have a scraper. Well, just as the name says, this would be responsible for scraping the surface material for whatever purpose they have. The grader for spreading it out, and here we have the drag line, which we looked at a bit earlier as well. The drag line would be used for digging, etc. Now, size of equipment is also an important consideration, and this is dependent on the size of the operation. Now remember, the size of the operation is not only the physical size of the landfill, but it also is a matter of how much waste is being handled. So where you have sanitary landfills handling, for example, 4 to 6 tons of waste per day or less, so that is in the lesser category, it can operate successfully with one 5 to 15 ton tractor, right? Heavier equipment can handle more, right? Heavier equipment in the 15 to 30 ton range can handle more waste and compact better. The heavy equipment, such as what we just mentioned here, the 15 to 30 ton heavy equipment, this is recommended for sanitary landfill sites that serve 15,000 people or handling more than the 46 tons, sorry. Right, so these are some of the numbers that would be associated with the type of or the capacity of the equipment. Now, how many of those types of equipment do we need? That's the next issue for consideration. So the last numbers of people being serviced we talked about was 15,000. So where you have landfill sites servicing 50,000 people or fewer, or handling about 155 tons of waste per year, you could still manage well with one piece of equipment, but it must be heavy equipment. But you must also have standby equipment on site, right? And not only in case of if machinery breaks down, but there will be times when your capacity has to be increased, or rather your operations have to be increased, because, for example, at times of the year like Christmas, for example, you find that the amount of waste coming to the landfill site will be increased. So there will be peak periods where you would have to make sure that you have standby equipment on site. So a second piece of equipment should be available for replacement in case of breakdown, and then routine periods of routine maintenance, for your regular equipment. The sanitary landfills that serve 100,000 persons or handling more than 310 tons of solid waste. So we have an increased amount of persons being serviced. More than one piece of equipment is required. So you see there's a relationship between not only the amount of waste, but the numbers of persons being serviced and how many pieces of equipment that you need, as well as the size of equipment. So at larger sites, specialized equipment can be utilized to increase efficiency and to minimize operations cost. Okay, so we have come to the end of today's lecture. I would like to thank you for joining me for today's lesson, and can you please proceed to e-classroom for today's activity? Thank you.